Hello, everybody. Today I'm going to tell you about compressed air, the hidden gold mine of energy savings. My name is Pascal van Putten. I'm CEO of VP Instruments, and my company offers industrial clients energy management solutions for compressed air, for technical gases, as well as other utilities. You probably all know the feeling when you return from your holiday, you come at home, and you find out that the tap was still open, dripping water into your sink, or even worse, maybe dripping water in your shower, and your whole shower has been flooded because the sewage system was clogged. That would probably make your return not a very nice day, and you would feel quite bad, right? So the same basically applies to industrial energy waste. Sometimes there's a lot of waste, and as soon as you start to measure it, you find out that it sums up to really big amounts, sometimes 10,000, sometimes even 100,000 of euros per year. And in this presentation, I will tell you how you can prevent these kind of losses. Lately, I was traveling to a client, and I had to use the airplane, unfortunately. Yeah, that is, of course, a very bad CO2 footprint. But I thought, well, let's make a little calculation here. What would be the equivalent of compressed air that I would need to save to basically compensate for my flight? Now, let's do the math. It's basically, if you take a 40 kW compressor, it equals around 960 kW hour per day. And if you take the average emission factor, for example, the US average emission factor, in that case, it would sum up to 355 kilograms of CO2, of carbon dioxide in 24 hours. If you look at the return ticket, Amsterdam-Paris, it's about 315 kilograms. So basically, you can compensate your next flight to your client or to your colleague by turning off a compressor. But you will probably wonder now, okay, that's nice, but how am I going to do this? Well, let's take a look in the next part of the presentation, where I will explain how you can do this systematically and how you can basically keep your energy consumption at the lowest possible level. But first, why compressed air? Why would you start saving compressed air in your plant? If you look at compressed air, it's about 8 to 10 times more expensive than the equivalent of electric energy consumption. And in an average plant, it's 10 to 30% of the electricity bill. And it holds a huge potential for energy savings. And there is a lot of low-hanging fruit, which is nice. So you can save a lot, but be aware, it tends to grow back on you if you don't monitor it properly. Let's take a look at that low-hanging fruit. This is an example of a production machine where someone has basically made her own air gun to basically clean the machine. This is not only dangerous, but these kind of air brooms also consume a lot of air, and they can also cause issues. For example, when everybody uses this gun at the same time at every machine, your pressure might be dropping to a lower level, and then some machine might even go into a failure mode. So this kind of low-hanging fruit is quite easy to resolve. Buy a good air gun with an air amplifier, or even better, take a broom next time to clean off the machine. And don't use compressed air at all. Other examples that we find in production plants are things like this. This is obviously not good. Here you see water on the floor, and water comes from basically from the air coolers in the compressed air system that basically dry the air out. And this water, this condensate, is normally collected in these big vessels here. But what you see here is basically flooding on the floor. So there is also an environmental aspect to this. And if you look further into the system, this is really an indication also of very poor maintenance. So there's probably a lot of other issues as well. So sometimes just walking around these plants, you can find a lot of this typical low-hanging fruit and things you can improve. So how does a compressed air system look in an average plant? So this gives you an overview of the entire system. So you see the compressors on one side that generate the compressed air. Most of the time they're in the dungeons of the factory, or in a separate building, or sometimes they're on the roof on the top floor. So it's not always the best place to go to. but you should go there because there is a lot of savings also to be found in the compressed air room. And then if you look at the demand side, you have the machines, you have the people that use compressed air, and it's all being interconnected by a pipe system. And also demand side, you can find a lot of saving opportunities. I will come to that later. It's a fact that over the lifetime of a compressed air system, almost 3/4 of the total cost of ownership is basically energy consumption. So that means energy savings is really the biggest thing you can do here. I mean, the equipment sometimes is offered at pretty competitive prices, so there's not much to gain there. Maintenance, yeah, okay, that's a necessary evil. You have to do maintenance on your compressors. But if you look at where you can really make those savings is on energy consumption. So let's take a look into that. What is the return on investment then? Well, if you take a small system with 3 compressors that run for a certain amount of hours per year, and you would look at the total energy consumption of that system, in this example, it's about 75K per year. It's a fact that you can save 10 to 50% on this cost by just optimizing it, by reducing the leakages, by also changing the behavior of people that use compressed air. Now, let's take then 10%, the bottom line of this, so really the lowest, let's say the lowest scenario here, 10% savings. That will already give you a budget of 7.5K, which can buy you, for example, a flow meter, a basic monitoring system, and also some money to fix those leaks. So you can start really small and have already an ROI of less than a year in this example. Okay, so how can you do this? Measure, discover, and save on the long term. Some more examples. This is a cacao factory. In this case, they did an audit. They installed a flow meter on some main lines, and they found out that the efficiency of the total compressed air system was not that great. So they did some optimization of efficiency, but last but not least, they also reduced leakages on machines. And this really was the biggest eye-opener. 50% of the compressed air was basically wasted in one of the cacao presses. And they were able to fix those leaks. And on the same time, also the speed of that machine went up. So they could increase also the production. So in the end, 14,000 euros per day increase in production capacity. No capital investment in a new machine. They could basically grow the production with the same machines. And they saved also in excess of 100,000 euros per year on the compressed air energy consumption. Another example, it's a car manufacturer where they basically installed also a control system to optimize the compressor controls. And in this way, they were able to also save a lot of money on their energy bill. In this case, they were able to stop some compressors from blowing off air to the roof. And they were able also to absorb large peak demands by using a big receiver. Total savings, almost 600K per year. So what's the value then of measuring and monitoring compressed air? Well, with measuring and monitoring, you can detect waste on time. You can benchmark machines, or you can even benchmark entire plants and compare one plant to another plant. You can optimize service intervals, optimize maintenance, and you can also understand the impact of new production equipment. If you buy maybe 2 other machines, what will be the impact on the compressed air consumption? What will be the impact on your electricity bill in the end? So it really is a source of valuable data for investment decisions. And last but not least, also the data can be used to get rebates from government. For example, in some countries, you get money from the utilities to basically save energy on your compressed air. So how does an energy management system look? Basically, it's a collection of sensors that you put on crucial spots in your compressed air system. For example, you will measure the power consumption of the compressor. You will take dew point. You will take consumption from some production lines. And it's all being collected nicely in a simple, easy to use dashboard where you can basically see KPIs. You can have alarms. You can get reports, which will help you basically to make your daily decisions on where to optimize and where to save. So how do you start? We advise always to take a sort of stepwise plan, which starts with a quick scan. And during the quick scan, you will do basically a walkthrough to your plant. You will talk to some people, ask about maybe problems they have with production. And very important, you will monitor also the main consumption of the plant using a flow meter that can measure flow, pressure, temperature, and can data log also that data. Now, after this quick scan, you start to analyze that data and discuss it with your team and basically rank your savings top 10. You might find out, for example, that during the lunch break or during shift change, that there is a lot of basically base load consumption, which indicates that there is leakage. So you might want to start with a leakage campaign to fix those leaks. Then you start to implement those three things, the top three savings measures. So you start with fixing the leaks. Maybe you will change the air guns, which I showed in the beginning of this presentation, that you will take more efficient air guns, or you will eliminate completely the air guns and buy some brooms. Maybe you find out also downstream that there is someone using air for cooling, where you can take a blower instead of basically using 8-bar compressed air to cool some kind of process. And last but not least, you will also install a permanent monitoring system. And this can be a small system, just to measure the main consumption and to measure the compressed air, basically the generation side, so it's to measure the compressors. But this permanent monitoring system is really crucial because this will help you to go back to step 1 and do your quick scan again and again over time. Because this should be really a permanent process backed up by permanent monitoring. That's really key to this. If you don't do this, what will happen is basically that the leakage grows back on you, the problems start to occur again, and then you probably will end up with the same amount of waste over time as you had before this campaign started. So you can start really small. Basically take a flow meter with integrated data logger that reveals leakage. It can record the nominal consumption. It can record peak consumption. It helps you to specify machine capacity. It can reveal pressure issues on the demand side or on the supply side. And it can also detect reverse flow. Sometimes you will find out that that the air is not flowing from basically from one side to the other side of the production area, but it might reverse because there are multiple compressors, for example, on multiple locations in the plant. And it's very important to start downstream. You will find most of the savings normally downstream. You will find excessive consumers of air. You will find pressure issues, which you can easily resolve sometimes by buying a receiver tank near the process that needs a little bit more air at some time of the day. You will find these inappropriate uses, the air guns or open blows. And also you can find maybe some applications where you can use a blower instead of compressed air. So to conclude, why is compressed air your hidden gold mine? Well, it can reveal savings between 10 and sometimes even 50% of your electric energy bill associated to compressed air. There is a lot of low-hanging fruit. The return on investment is often less than 12 months. And permanent monitoring is really the key to continuous energy savings. So that's it. If you have further questions, please reach out. And there's also some time after this presentation to answer questions live. Thank you for watching.